Hi. Okay. So today we are going to be doing acids and bases. So we're going to go over some definitions and ways of measuring pH stuff. Okay, so there are three main definitions of acids and bases. The Arrhenius definition is the most selective and most basic, I guess. So an acid is a hydrogen-containing compound that can donate hydrogen ions in dissociation with water. So when it goes into the water, the ions will separate and it will have more positive hydrogens. A base is a hydroxide containing compound which donates OH minus in dissociation with water, and OH minus is hydroxide. Strong acids and bases will dissociate completely, where almost all of the molecules will donate a hydrogen or a hydroxide, but weak acids and bases will not dissociate completely. So that's like a diagram of acids and bases. So when the HCl goes into water, it separates into the hydrogen ion and the chloride ion. And when the sodium hydroxide goes into water, it separates into the sodium cation and the hydroxide anion. So there's also the Bronsted-Lowry definition, where an acid is a proton acceptor and a base is the acid is a proton donor and the base is a proton acceptor. So conjugate acids and bases is what's left over when the proton is accepted or donated. And strong acids have weak conjugate bases, strong bases have weak acids, vice versa. So here we have water, which is a weak acid in this case, and it donates a proton to the base, which is NH3. And then it gets the conjugate base, which is OH minus, which is a strong base, and the conjugate acid, which is NH4 plus, which is a weak acid. So acids and bases have different properties. Like acids conduct electricity and bases also usually conduct electricity because they have those ions. Acids react with metal to form a hydrogen gas. They taste sour because when you're tasting sourness, it's actually just like a measure of like how acidic it is, essentially. And some acidic things are like lemons, vinegar, soda, sour candy, anything that's like sour. Bases, they also conduct electricity due to those ions. They feel slippery and soapy a lot. They're bitter in taste, and an example is like baking soda. And both of them are very dangerous if they are concentrated enough. So these are just a list of strong acids and bases. And if you go to a chemistry class, they will probably make you memorize these. But basically, you can tell that acids have a hydrogen in them and bases have a hydroxide inside. And in water, the hydrogen proton usually goes into the water to make H3O plus, which is hydronium. Okay, so an amphoteric substance, amphoteric means each or both in Greek. So it means that they can be bases or acids depending on the circumstances. So water is an amphoteric substance. So are like amino acids, proteins, metal oxides. So autoionization of water. In amphoteric substances, the substance can have acid and base pairs of themselves. So in water, there's always a little bit of hydroxide and hydronium inside because the water will kind of react with itself to make those ions. Dissociation constant. So the dissociation constant, is represented by K. So the dissociation constant of water is the molarity of the hydrogen ions and the hydroxide ions multiplied together, and they always equal 1 times 10 to the negative 14th. Okay, pH and pOH. So pH and pOH is just a measure of how acidic or basic a substance is. pH is the negative log of the concentration of hydrogen ions, and pOH is the negative log of the concentration of hydroxide ions. And pH plus pOH equals 14 all the time. And if pH is less than 7, it's acidic. If pH is greater than 7, then it's basic. And you have to remember that's on a logarithmic scale. So as pH goes down or up by 1, the number of ions don't just increase by a constant pace the whole time. It actually goes up or down by a factor of 10. So as the pH decreases by 1, it gets 10 times as acidic. So these are some examples of substances along the pH scale, and basically water is neutral all the time if it's pure water. Yeah. Ka and pKa. So Ka is the acid acid equilibrium constant. So it's just the products over the reactants. So it's the H plus ions times the conjugate base over the acid. That's in molarity. And pKa is just the negative log of the equilibrium constant. So the higher the Ka, the more acidic it is. But since pKa is the negative log of it, that means the lower the pKa, the more acidic it is. And then very acidic substances will actually have a negative pKa. Neutralization reactions. So when you put acid and the base together, they react to make water and salt. So the first thing that happens is that the acid and the base dissociate, and then the H plus and OH ions form water, which is H2O. And then the remaining ions form a salt. And there are many definitions of salt, I believe, but one of them is just the product of a neutralization reaction. So in this example, HCO plus NaOH goes to H2O and NaCO, which is table salt. Why do acids taste sour? Well, okay, so the hydrogen ions trigger the sour taste buds, and they do a lot of stuff to your food. Bases, they're mostly used to neutralize acids because they can be used to produce carbon dioxide when they do. Okay, so Lewis acids and bases. Acids are electron pair acceptors and bases are electron pair donors. So in this example, water is a base because it can be a base or acid because it's amphoteric, and CO2 is the acid. So that electron pair from the oxygen is going to the carbon, and then they go together to make carbonic acid. And here the base is water, goes to that thing, donates the electron pair to the carbon. And then it forms that and hydronium ions. Okay. I can answer any questions now. I know that was really quick. Okay. Yeah, so has 2 plus atoms, that's like a compound or like a molecule. Uh, B has sour taste, that's like a trait of acids, but it's not what makes an acid. C, acids, according to the Arrhenius definition, they donate hydrogen ions, so that is correct. D, that's actually the Arrhenius definition of a base, not an acid. Okay. Which of the following is basic? Okay, so bases, anything that has a pH of more than 7 is a base. pH of 2, that is extremely acidic. pH of 7 is actually neutral, like water is usually pH of 7. And pH of 12 is really basic. So let's see. Okay, does pH plus pOH equal 14? Okay, this one is true because remember the amount of hydroxide ions and hydronium ions have to multiply to 14. I mean, they have to multiply to 1 times 10 to the negative 14. So because of that, pH and pOH always equal to 14 when you add them up. So it's true. Okay, number 4. Okay, this one is true because when an acid and a base react, they form water the hydrogen from the hydrogen ion and the hydronium. They make water, and then the salt is just like the other thing that's being made. Until all acids completely disassociate in a solution. Okay, so this one is false because only strong acids completely disassociate. Most acids are weak, so they only partially disassociate in a solution. Okay, so that is it. I'm surprised we went through it this fast, but I can answer any questions that you guys have, and then we'll do some like practice problems. Okay, so if you guys ever come up with any questions, feel free to drop them in the chat. But we're gonna do some problems now. I know you guys are like only in, some of you guys are middle schoolers, so do you guys like know what logarithms are? Because those are like pretty important. Okay, that's cool. Okay, yeah. Logarithms are just like the inverse of an exponential, essentially. So like, it's just an exponent rewritten. Like if a to the x equals b, that means log base a of b equals x, essentially. Okay, so number one, is HCl an acid or a base? And you guys should be able to tell by if it has a hydrogen in it or a hydroxide. Yeah. Okay, this HCl is an acid. It's actually a very strong acid. It's called hydrochloric acid. Okay, what's the Arrhenius definition of a base? Oh yeah, and I'll drop the link to the slides in the chat if you guys want to be on it. Okay, so the Arrhenius definition of a base is just that it donates OH minus or hydroxide ions when it dissociates in water. Okay, what is the definition between strong and weak acids? Okay, so strong acids completely disassociate or like donate the protons all the time, and weak acids only disassociate sometimes. So the equilibrium for weak acids is going to be a lot further to the left, as not all of it is going to disassociate. Okay, so it has a pOH of 8. Find the pH. And for this, you just have to know that pH and pOH add up to 14. Okay, so since pH and pOH add up to 14, that means that the pH is just 14 minus 8, which is 6. And since the pH is less than 7, it's an acid. Okay, is lithium hydroxide an acid or a base? Okay, so you can tell that lithium hydroxide is a base because it has dihydroxide ion inside. Okay, how do you find pOH? Yeah, okay. It's 14 minus the pH, or if you can take the negative log of the molarity of the hydroxide ions. Okay, so for number 7, when writing the product of a neutralization reaction, remember that it has to make water and then a salt. Not like table salt, but it can just make like any salt, you know? Okay, so basically what you have to know is that the hydrogen ion from the HCO and the hydroxide ion from the sodium hydroxide is going to make water. So you know that's going to make H2O. And then the stuff that's left is just sodium and chloride. And the cation goes first, so that's NaCl, a table salt. So try to do that for number 8. Okay, so for this one, it's the same thing. The hydrogen from the okay. So the hydrogen from the hydrobromic acid and the hydroxide from the potassium hydroxide, one, it's going to make water. So you know that takes care of the 2 hydrogens and oxygen. And then you just have potassium and bromine left. And the cation goes first, so it's KBr. Okay. Okay, so an acid has a hydrogen ion concentration of 0.01 molar. What's the pH? So for this one, you have to use a calculator basically, or you could do it in your head. But you can use the log base 10 button on your calculator for this one. Okay, so remember that pH is the negative log of the hydrogen ion concentration. So that's negative log base 10 of 0.01, which is 2. And that's actually very acidic. Okay, so the same thing is for number 10, except for you have to do the POH and then do the POH plus pH equals 14 thing to get the pH. Okay, so for this one, you'd find the POH first, and the POH is negative log of the OH concentration, which is 0.001 molar in this case. And that equals 3. So since pH plus POH always adds up to 14, that means that POH is 14 minus 3. Wait, okay, we just solved with the POH, so the pH is just that, and 14 minus. Okay. So now we're gonna do a different one. Okay. So which of the following ionic salts is a weak base? So on the slideshow, there is a slide with the strong acids and the strong bases. And basically, if it's not on that list, then it's a weak acid or a weak base. So, and you just have to memorize these. So lithium hydroxide is on the list, and so is sodium hydroxide. The magnesium hydroxide is not on the list, but you can tell that it's still probably going to be a base. So the answer to number 1 is A. Okay. Okay, for number 3, you guys should try this one first. Okay, so in number 3, you can see that the water donated a proton to HPO4. So, and then it turned into hydroxide. So since water gave away a proton, that is an acid. And a conjugate base is just what's left over of the acid after it disassociates or gives up that proton. So that means hydroxide is the conjugate base. So the answer is A for this one. Okay, number 4. Which of the following is not a conjugate acid-base pair? So remember, conjugate acids and bases, the conjugate acid or the conjugate base is just what's left over after the other one is associated. Okay, so since conjugate acids and bases, it's just what's left over after it disassociates. This one would be B. Because this one is the base and then the conjugate acid. And all the other ones are the acid and then the conjugate base. Okay. Okay. So Bronsted-Lowry is the one where one is the proton donor and then one is the proton acceptor. And the conjugate base is okay. So HAC, that would be the proton donor because you can tell it has that hydrogen ion. So therefore A and C cannot be bases. Okay. AC minus can be a base because it accepts the proton and then becomes HAC. Okay, phosphate, that can also be a base because it can also accept protons in order to balance its charge. And water can also be a base because, as you remember, water is amphoteric, so it can be an acid or a base depending on the circumstances. And NH4 plus, that would be a proton donor and not an acceptor, so that would be an acid. So the answer to number 5 is B. Okay, we haven't done redox yet. Okay. So if the concentration of hydrogen ions in a specific solution is a 1 times 10 to the negative 7 molar at this temperature, then the solution is which of the? So you can calculate the pH from the concentration of hydrogen ions, and from that you can tell if it's acid, neutral, or basic. Okay, so if you take the negative log of 10 to the negative 7, then that's 7. And 7 is neutral. And so since the pH is 7, you know that has to be neutral, and the answer is B. Which of the following has a pH lower than 7? So that means it has to be acidic. Okay, so I didn't exactly say this, but human blood has to keep a very small range, so it's almost neutral. Orange juice, you can tell because it has oranges in it, and oranges have a lot of vitamin C or ascorbic acid, so orange juice is acidic, which means it has a pH lower than 7. Sucrose is not acidic, and gastric juice, I believe, is hydrochloric acid, which is very acidic. So 2 and 4 have a pH lower than 7, so the answer is B. Okay, 13 is a fun question. So basically, you have to find out whether they're strong or weak first, and then calculate the concentration of hydroxide and hydronium ions, and then you can see if the pH is going to be greater than 7. Okay, so for one, HCO and NaOH, they are both strong acids and bases, so they both completely disassociate. But since they're the same amount of each, they would neutralize each other, and the pH would be 7 or neutral. For 2, HCO is a strong base, it's a strong acid, and barium hydroxide is a strong base. But barium hydroxide has 2 hydroxide ions attached to it. So when it disassociates, it has twice as much of the hydroxide than the hydrogen ions. So that means it will lean more towards the basic side, which means the pH will be greater than 7. So you know it has to include 2. So the answer has to be C or D. For 3, acetic acid, you can Google what acetic acid is. And basically, it donates like it donates 1 proton, and pH, and sodium hydroxide is a strong base, but it gives you the pH. So because pH is the negative log of the hydrogen ions and pOH is a negative log of the hydroxide ions, you can find the amount of ions from doing 10 to the negative pH, because exponents are like the inverse of the logarithm. So when you find out, you'll know that there's 10 to the negative 4th molar hydrogen ions and 10 to the negative 4th molar of hydroxide ions, and that is the same, so they will neutralize each other. So C can't be right. So it has to be D. But for D, HCO, that is a strong base. It's a strong acid that donates 1 proton. So that's 10 to the negative 4th. And ammonia water, the pOH would be 4. So ammonia water is going to be basic, which means that it has to be. Okay, so we have 10 more minutes of class, so I'm just going to end it here. And you guys can ask any questions that you have. That's going to be about this lesson. And you guys should also complete the feedback form. That's in the chat now. Where can you find a recording for yesterday's classes? They're going to be on the KTK website. I'm going to send a link when I find it. So I'll put it in the chat now. No problem. So what do you guys do for extracurriculars and stuff? I guess, since you have extra time. Swimming, yeah, and swim is fun. Okay. Why do you guys decide to do this in your summer when you could be doing other things?